Okay, on this problem we're looking at the function y equals x squared, and we want to find the point on that graph or that function that's closest to the point 3, 0. So here's point 3, 0. Y equals x squared is just your parabola, at 2, 4, negative 1, 1, negative 2, 4. Just your regular, of course, goes through the origin. Regular parabola that that you've known and loved for a long time. Okay, so any particular point on this parabola has the coordinate x comma y, but you're told that y is equal to x squared, so it has the coordinate x comma x squared. And if you wanted to find the distance between these 2 points, you would use the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. But that's yucky if you're going to be taking the derivative of it and such. So you're not going to lose anything or any information if you consider the square of that formula, which looks remarkably like the Pythagorean theorem. You probably know that because the distance formula is based on the Pythagorean theorem. So the square of the distance formula, if you minimize that function, it's going to be the same as finding the minimum for the distance formula. It's going to work out. So we'll just plug in our points here to create our function that we're going to optimize. Okay, so this was the point 3, 0. So we'll do 3 minus x squared plus 0 minus x squared squared. And so when you FOIL this out, this is 9 minus 6x plus x squared plus x to the 4th. And so the derivative is negative 6 plus 2x plus 4x to the 3rd. And we want to find the critical numbers for that, so we want to set it equal to 0. So you can divide this whole thing by 2 without losing any information. And so that would be negative 3 plus x plus, that'd be 2x cubed is equal to 0. It's the same thing, just dividing everything by 2 will simplify things a little bit. Now, if you're having a good day and you just stare at it, you'll probably see that the solution to this is x equals 1. If you're not having such a good day, you could graph this and you could see that it crosses the x-axis only once at x equals 1. So either way, with your calculator or with your brain, you can see the solution to that. So this is your critical point. Now you want to verify that's a min by looking at the second derivative, which is what? 2 plus 12x squared. And you look at the second derivative at the critical point, and you get 2 plus 12 times 1 squared, which is all you want to know is that it's greater than 0, which means that the function is concave up there, and you should be able to determine that this second derivative is always positive, so the function itself is always concave up, the original function. And so since it's concave up at its critical point, we know that that critical point is a minimum. So x equals 1 is a min, and then the y coordinate, of course, is equal to x squared, which will just be 1 squared. So the coordinate 1, 1 is the coordinate, or the point on the graph right here. So this is actually this point right here, 1, 1. Oops. That is closest to the point 3, 0 on the parabola.